can do or algebra or calculus and algebra. So, who would like calculus and algebra? Who would like just calculus? Who would like just algebra? Okay, I'm going to put do both. All right. Now, firstly, your lab test 1 is next week. It will be in the time and location shown in your student timetable on my UNSW. It will be marked as the other class. All right? What to bring to the test? ID is the most important. If you don't bring your ID, you cannot sit the test. If you bring a passport, it's not okay. You need your student card. Okay? You need your UNSW student card. If you forget a pen or a calculator, that's okay. You can borrow one. Okay? But you can't borrow a student card. All right. You cannot bring paper. You cannot bring notes. You will be given paper. Okay? And then you give it back at the end. The best way, and what we're going to do today, is do the practice tests. Okay? If you do them, you'll be fine. Yes, the ones that are online. Maple TA. We'll do some today. Now, this is important. UNSW has a new policy. If you turn up to the test, you are saying that you are healthy. Unless something happens in the test, then you must inform someone. Okay? If you turn up to do the test and you don't say, oh, I don't see halfway through, you cannot have special consideration. So these are the most important things. Okay. So I want you to get 100%. Is that okay? You guys get 100% for the test, please. I know you can do it. I want you to do well. I want you to get 100. Just do it. Okay? Let's start with the calculus problem, because I know you just had an hour classes. What I'll do is, so if you're watching at home, I'm going to put this on the other screen. Okay. Limit questions. You can't have calculus without limits. It's just not possible. So, we're asked to select all the statements that are true regarding the following 7 limits. Okay. So you guys can tell me. True or false? True or false? The limit as cosine x, as x gets large and positive, does that exist? Is it true or false? False. False. Why is it false? Yeah, cos x just goes up and down between positive 1 and negative 1. It doesn't approach anything. Okay? So that's a false. What about, oh, I guess I can do it on both things. Oh no, that was the wrong one. You, come back. I'm thinking about you people watching at home now. The second one. Limit of cosine x over x as x approaches positive infinity. Does it exist? True or false? True. Why? Who can explain it to me? Yes. Pinching theorem, right? Squeeze theorem, pinching theorem. The idea is when you divide cos x by x, there's a battle between the denominator and the numerator. And this battle, the denominator wins. Okay? tells you the answer to part 3. If this is true, then this obviously is false, okay? Because how can it not... if this is false, then obviously it can't equal 0. Okay, next one. True or false? Cos x over x, limit as x approaches infinity. True or false? True. Again, pinching theorem, squeeze theorem, sand. They also call it a sandwich theorem. Okay, next one. This limit is undefined. True or false? True. Absolutely true. This limit is undefined. The cosine x over x. True or false? False. Right, we know it's 0. So, and lastly, ooh, this limit of the sum is undefined. Is it true or is it false? It's definitely true. Because the second part is undefined. Okay? So, definitely true. Alright. Let's do one where we actually write something down. Choose one here. I'm just choosing one here. All right. Yeah, this will do. Yeah. Okay, all right, let's do this one. Okay, this question is a vector type question. You've got a Cartesian equation for a line, and then you've got the PVF, the parametric vector form. And then they say a choice for A is -1, -4, -1. Choose a different point and a different parallel vector. Okay? So how might we do that? And then in the second part down the bottom, you're asked to show does this point C lie on the L? Okay, so let's do that. Okay. So we've got the line L is x plus 1 over 4 equals y plus 4 over -6 equals z plus 1 over 6. Okay, and I'm going to write in the little sneaky lambda, the little parameter over there. Why do I want to do that? I will show you. It's helpful. First, it's helpful because it connects Cartesian with PDF, but it's helpful for this question. Okay? So, who can tell me how can I find another point on that line L? How can I do it? Anyone know? Yes. You said that? Yes. Awesome. If I let lambda equal 1, then I'll get something for z, something for y, something for x. Do I have to choose lambda equals 1? No, I can choose any value of lambda. So what you're doing is you're saying, right, I only want 1 point, let's make a choice for lambda and we'll get a point. Who cares what it is? What happens if I put lambda equals 0? What will I get? You'll get the same point that you're given here. That's the connection. Okay? So let's do it. Let lambda equals 1 so that you get 3 equations out of this, yeah? So we just rearrange those. So x is going to be 3, y is going to be negative 10, and z is going to be 5. So you would just enter the 3, negative 10, 5 as a vector. Okay? So you can say a new point A is something like this. Okay? All right. What about the V? We want to choose a different V. Not this one, not 4, negative 6, 6. I think we want a different one. So, if I don't want that, but I want a vector that's parallel to the line, how can I choose it? Right, any scalar multiple of V will also be parallel. There's a common factor of 2 in each of the bits, so maybe we just factor them out and disregard them. Okay? So another parallel vector to the line L is, well, let's just go 2, negative 3, 6. 2, negative 3, 3, sorry. So you would enter that in the second box. Now, third one. Does the point C lie on L? So what, you can do this a number of ways. What I'm going to do is just go up here and plug in negative 17, 20, negative 25 for x, y, and z and see if they're all equal. Sound okay? So let's call that, you guessed it, star. Okay, so we're going to get negative 17 plus 1 over 4. That's going to be negative 4. That's the first bit. So over here we're going to get 20 plus 4 over negative 6. So that's going to be negative 4. Oh, they're equal so far. Last one, negative 25 plus 1 over 6. What's that going to be? Negative 4. They're all equal. So does the point lie on the line? Yes. Yes, it does. So we would tick yes. Of course, when you're doing these problems, you would do them much faster than I'm doing, right? You would do them much faster. Questions? Questions? Okay. Oh, that's so bad. What's going on here? Hey. Okay. Let's do another problem. Shall we do calculus one? Calculus. All right. Let me find a calculus one. Aha! Oh, it's a good one. Okay, let's discuss this. We've got x to the 9th here, and the suggestion is we divide maybe the top and the bottom by x to the 9. Why? Ah, the teacher, Professor Lee Zhao said so. Okay, it's correct, right, yes. This is a strategy. But let's see what happens if we make this substitution, right? The division. But before we do that, what happens if we take the limit of the top and the limit of the bottom as x approaches infinity? What do you get? Well, maybe infinity on the top and infinity on the bottom, or maybe not defined on the top because you got sine x, and infinity on the bottom. It's very confusing. Okay? And infinity divided by infinity is not necessarily 1. Some people will tell you that it is, but it's not necessarily 1. So let's try this division and see how we go. And who knows? We might get negative infinity. Who knows? All right, let's have a look. It's so annoying. I've got to push so many buttons because I'm thinking about all those people at home who are watching on Echo. Because Echo 360, it only records one screen, right? So if I put it on the wrong screen, they can't see it at home. So, okay. So what have we got? We've got consider. All right, now I'm going to divide the top and the bottom by the highest power in the denominator. Oh, it's a mess. But what you can do, you can divide x to the 9 into each part, top and bottom, and you'll get a little bit of simplification. Okay, so I'm going to get something like, I guess I'll do it like that. Okay, that's sort of the top taken care of. And in the bottom, you're going to get that. Okay. So, how does that help? It's 0 on the top. Is it 0 on the bottom now? No. Why? Because you've got a constant. That is why it works. Because the constant on the bottom, as long as it's not 0, make sure that the bottom can't be 0, can't be infinity. So that is why it works. It's just a basic algebra. Okay? So what happens to this limit as x gets large and positive? It goes to 0. This one? 0. What about this one? 0. Why? Pinching theorem. What about this one? 0. What about this one? 0. This one? 0. Yes. So we've got 0 over negative 2. It's 0. Okay? Now, of course, you don't have to write it all down. It's up to you. Questions? Okay. Let's do algebra. Yeah. Oh. Yeah. Okay, here we go. This is an interesting question. Let me share my screen. what we do with these kind of problems is we do a scalar triple product. So OA dot OB plus OC, and take the absolute value. But we're given some extra information here. But be careful. Two parts of the information are really not useful. They're like a distraction. How rude. They give us this information and it's like a distraction. I think it's a distraction. So let me show you what I mean. Yeah. No. Yeah. Okay. So we've got A, B, oh, is that positive 3? Yes, so that's a positive 3. Okay. Now, usually what we would do here is go, the volume of the remember, the parallel pipette is like a three-dimensional thing. Something like that, right? Yeah. That's what we would normally do. But let's think about the information that we've already got. We already know OA cross OB. So can I rework this into something where we can use the first cross product? Yes. Okay, let's try. Good. So I would probably do this OC dot OA cross OB. Because the order doesn't matter because it's volume. Okay? The order doesn't matter because it's volume. It doesn't matter if you parallel pivots like that, like that, like that, like that. It always has the same volume. Okay? It always has the same volume. So instead of writing a big determinant, let's use this information here. Okay? So OC is 5 to negative 4, and the dot product, the cross product is just that. Okay? That is, it's given to you. So we don't need to do scalar triple product. All we really need to do is a dot product. Okay? So what are we going to get? 35 plus 102. That's it. So remember, you can do the scalar triple product either using a big determinant, or you can do it separately. Do the cross product, then the dot product. Work smarter, not harder. All right. What have we got left? Oh, yeah. Calculus? Yes? Algebra. Algebra? That's two hands. Calculus? Algebra. I'll do one calculus and one algebra. Is that okay? Let's do it. Okay, let me see if I can find it here. It's so funny, right? Like, let me see if I can share this with you. I've got all these screenshots, right? And I don't know what's where. So, oh, I know. Ah, that's it. That's the one I wanted. Okay. It's like I don't know how that photo got in there. All right. It is a limit question or a continuity type question. Okay. It's a split function. So when we talk about split functions, it means we define them in two ways. So you can see we've got the x squared minus 25 on x plus 5 and a 0. Okay? So for this one, let me just move it over. We're asked to look at the limits as x approaches -5. So left-hand limits, right-hand limits, and then there's a drop-down box, okay? So let's have a look at this. So we define the function in this way. And 0 at the point x equals. Okay, so what I'm going to do with that function, I'm going to simplify the top part. Okay, I'm going to simplify the top part. So x squared minus 25, difference of two squares. So actually, the top part is very simple. It's a linear function. So can I draw this function? Yes. If I want to, I can draw it. So let me draw it, right? So there's our axes. This is going to be -5. At that point, the function's 0, so I'm using this information here. Everywhere else, it's the line x minus 5. Okay? That's a rough sketch of your function. What is happening to the function as we approach this point? So down here, what's this value? So who can tell me what are these two values? What are these two things? Who can tell me the values? What is the left-hand limit and the right-hand limit and the left-hand? What are their values? -10, because you can see, you're absolutely right, you can see that, let's say you're walking along the axis, right? You're rendezvousing, your parents aren't home or something. And you're rendezvousing, okay? As those people walk towards the point, they're looking at the graph. And they say, what value is the graph approaching? And you can see over here, you're approaching -10. Okay? So both of these are equal to -10. So, who can tell me what is this value? This one's -10, this one's -10. What is this? -10. It's not a difficult question. Okay? So there would be some drop-down list there saying, well, the limits exist or whatever. You just need to choose the right one. This is the important information. All right. Second question. There's a discontinuity. Can you turn the function into a continuous function by doing something what you're doing is you're saying, oh, there's a hole there, I'm going to plug that hole. Okay? So what you would do, you would say, forget about that, that's my new thing. Okay, so I would say let f of -5 be -10 for continuity. So you'll just enter -10 here, right? -10.
So yes, there's this exact same question in the practice exam, except there was x plus 4. And so you couldn't cancel out. So how would you solve that?
Oh, okay. So I'll put one on. Yeah. Shall I do one of those now? How much time? Yeah, we've got enough time to do that. Should we do it? Yeah. Yeah. Okay. Good. All right. Let me just find my notes because it's a harder question. Aha. Okay. So you probably had. What? What? What's that? Oh, let me kill that. Calculus. That one. Is that it? Is that similar? Okay. Let's do that. Okay. This is a more difficult problem. Oh, all those people watching at home. I need to show you this. No, I don't. Okay. So it's a split function. It's defined in two ways. And you've got an absolute value in the top part, and it's a bit strange. What they're interested in is what's happening near x equals 1. Okay? So it's very similar to the previous question, but a little bit harder because you can't factor it out. Okay? So this is similar to yours, but not exact. Okay. So how do we do it? Well, what I'm going to do is I'm going to simplify this denominator as much as I can to see if anything happens. Okay? So, let's have a look. All right. So I've got this one. I'd like to simplify this. I can factorize it. Okay? And what I can do is I can draw it. Just draw what's in the middle and then reflect it. Okay, so that is this, and if I want to take the absolute values, it'll be that. Okay? Okay, so all I've done is I've drawn the simple graph, then I've reflected the negative part to the x-axis, and that's my absolute value. All right. So, what's going to happen here? Well, I'm going to see if I can simplify this in the following way. You can see here that this is negative. Right? That's the negative of that. So I'm going to break it up into cases depending on where x is. Okay, so let me just see if I can simplify this, or actually make it more explicit. So I've got x plus 3 over this mess. It's 0 at those points. And it's this thing otherwise. Okay, so by otherwise I mean at all different points, at x not equal 1 and not equal 3. Okay, so let's have a look. For x less than 1, the orange curve and the blue curve are the same. Would you agree? For x less than 1, the orange curve and the blue curve are the same. So we don't have to worry about anything, right? So this bottom bit will just be the same function without the absolute value signs. Okay? At x equals 1, the function's 0. So I've done that bit, I've done that point, and I'm going to do this point now. You can see in this picture the orange is the negative of the blue. It's a reflection. So between this point, this thing will be negative. Negative. Okay? At x equals 3, the function's 0 again. And then you can see here the blue curve and the orange curve are the same. So there are all your parts, all your forms of this crazy function. Okay. So what is the question asking us? The question is asking us, what happens near x equals 1? What happens to this function? Oh, sorry, this should be 1. Sorry, that's 1. X equals 1. It's 0 at x equals 1. Okay? So the question is asking us, what is this? And what is this? Okay? That is really what the question is asking us. So, let's just use our different parts to answer this question. For x less than 1, this is our definition of f. And you can see it doesn't cancel, which is annoying. Okay? What would this limit be? Top will, when x is really close to 1, this will be something like 4, right? Something like just a little bit less than 4. What about the bottom? This will be something close to -2. But what about this? 0. 0 from the left-hand side. So what will the actual limit be? You've got positive times a negative, right? So this bit, if you just put this in here, this bit's going to be positive, right? It'll be close to 2. This bit's going to be positive, so it's going to be negative, right? That's going to be close to -2. This bit is going to be smaller negative. So the probably shouldn't put equals there. I'll put an arrow. Okay. So the left-hand limit goes off to negative infinity, according to my calculations. What about the right-hand limit? Let's have a look. So as x approaches 1 from the right, this is our function. So what is going to happen with that? Well, as x comes in from the right, that's going to be slightly more than 4. This part is going to be negative, negative 2. And this bit is going to be small and positive. So I've got a negative, negative, positive, and the top's positive. What's it going to go to? Yeah, positive infinity, right. So the question now is asking you probably something like, are the left-hand limits equal or something like that? They're obviously not equal. One of them goes to positive infinity, one of them goes to negative infinity. Can you answer the second last part of the question? Is there a hole? Is there a hole? So Phil, well, let's draw a little picture. Okay, that's the 1. It's got a that. In this case, it's going like that. In this case, it's going like that. Can you plug the hole? No. It's impossible. So can you make this function continuous? Absolutely not. You cannot do it. Okay? And so they say, if you can't do it, write none. Okay, write here. Write none. But not with the apostrophe, the inverted comma. Right? Just N-O-N-E. No. That is a hard question. That is a hard. I hope you don't get a question like that. That's why you're independent. Anyway. All right, let's do one last algebra. I promised you an algebra. Let's do the algebra. Okay, let me find it. Oh yeah, okay, this is a good one. Okay, let me see if we can do this. Okay, 3 points, ABC, you're given a PDF, parametric vector form. You're told V1 is parallel to the plane. How do you compute V2 and V3? V2 and A. So, who can tell me, what is 1 point on the plane? A? Any others? B and C. You can choose any of them. Okay, I'm going to choose A because I'm a very simple man. Right? I'm going to choose A. So for this one, you would enter that in there, or that in there, or that in there, or another one, something else. Okay, how do I get V2? Anyone suggest anything? Right, so if we took, let me see if I've got my work here. Yeah. Let me just push it over. Huh? There are your 3 points. Is that the right symbol? Yes. Okay. The only thing you have to be careful of is choosing the right vector. You do not want this to be a multiple of this. You don't want V1 to be parallel to V2. Okay? You do not want V1 to be parallel to V2. So you've got to choose the right points. Okay? That's the only small problem with this question. It's actually very easy. Right? You need 3 points for a plane. You're given a vector. You're given 3 points. So it's very easy. Okay, so just to remind you for the test next week, you can find it in your student timetable. If you turn up to the test, you are saying, I am healthy, unless something happens. You need to bring your student ID, pens, and a calculator. Where can you get your calculator approved? In the maths office, science student center, or Nucleus Hub. Need a little sticker. Good luck, get 100%. I'll see you next week.